Hello everyone. In this video we'll talk about angles and their measurement. When we think about angles, we are thinking about angles in standard position. An angle in a standard position is basically the angle that has a vertex on the origin. Here, that's the origin. And it has the initial side on the positive x-axis. Now the terminal side is going to be somewhere within the quadrants. So this is quadrant 1, quadrant 2, 3, and 4. So if I knew that the angle has a vertex on the origin, the initial side on the positive x-axis, it does not matter where's the terminal side. This is going to be an angle in standard position. Now for this angle, direction is going to go this way. Okay, so this is a counterclockwise, and the angle will be positive, where in this case the direction is a clockwise direction, so the angle will be negative angle. Okay, the measurement of the angle is going to be negative. Let's think about drawing some angles. If I draw this angle here, and I said maybe the angle is 45 degrees, then you are going to say, oh, okay, this angle, which is theta or 45 degrees, lies in quadrant 1. And it's a positive angle, so it goes counterclockwise direction. What about an angle here? So I could say, okay, if this is theta, then I would say theta lies in a quadrant 3. And it's a negative angle, so maybe the measurement of this angle might be negative 120 degrees. Where I could look at this in the other direction, something like this one here, then that's going to be a positive and again in quadrant 3. Sometimes I'm going to go and end up in here, let's say. So this is a 90-degree angle, right? But it does not lie in any quadrant, so we will call this angle a quadrantal angle. So a quadrantal angle is an angle in a standard position in which the terminal side is on one of the axes. So 90 degrees is one of them. 180 degree is the second. And I could say also this one, 270 degree is a quadrantal angle, and also 360 degree. So if I'm thinking about 360 degree, I'm talking about this is the initial side, and we go all the way till here. We call this one revolution. So I could go more than one revolution. So for example, if I decided to talk about 2 revolutions, then basically we are doing 360 twice. So 360 times 2, and that's going to be 720. So if I'm asking you to draw an angle, a 720 degree angle, and it's going to be for sure a quadrantal angle, I'm doing this. So this is one revolution and the second one. So that's again a quadrantal angle. Now, in this question, I'll ask you to draw negative 120 and negative 540. Okay, so well, we need to think about it. If I'm saying negative, then I'm going clockwise direction. Remember that the vertex should be in the origin, the initial side on the positive x-axis. Now the terminal side is something else. So if I'm saying 120, from here to here is negative 90, and from here to here is negative all the way negative 180. I want 110, 20, so it's going to be somewhere here. We don't need to be accurate though. That's negative 120. It's an angle in quadrant 3. Now, what about negative 540? Okay, so for negative 140, we are going to go clockwise also because it's negative. So from here to here, 360. And if I add 180, I'm going to end up here. So basically, I need to draw the terminal side. This is basically also, this is a quadrantal angle. Okay. Now, we will learn how to convert between the radian and degree. When it comes to an angle, we are using two measurements, either degree or radian. Degree is like 120 degrees, for example. Radian, when we are using, for example, pi, so 2 pi over 3. Now, in order to convert between radian to degree, we will multiply by 180 over pi. And if I want to convert from degree to radian, I'm going to multiply by pi over 180. Now in this question here, I want you to convert between from degrees to the radian. So I do have negative 135 degree. I'm going to multiply by pi over 180. Final answer is going to be negative 3 pi over 4. Now what about 125? Again, I'm going to multiply by pi over 180. And the answer will be 25 pi over 36. Okay. So now, what about if I have a radian and I want you to convert it into degrees? So you're going to do the opposite. You're going to multiply by 180 degree over pi. So 180 degree over pi will be negative 225 degree. Now what about here? Well, radian, the word radian here, replacing the pi. So when I say convert between 3.14 radian, I'm basically going to multiply by 180 over pi. And when you do that, you are going to get 179.9 degree, which is about 180 degree. Now, we are going to talk now about the central angle. What is a central angle? A central angle is an angle in which the vertex is basically the center of the angle, the initial side, and the terminal sides are radius. So this is going to be my theta. Now there are certain things that we need to know about this central angle. From here to here, that's an arc. We call it S. A radius is R, and theta is going to be in radian. That's the most important part. Theta, it's called the central angle, and it has to be in radian. So now there is a rule or a formula in which we can find the arc length, radius, and center angle. So the arc length is basically equal to the radius multiply theta, the central angle, and it has to be in radian. Or maybe I want to find the radius out of the arc over the central angle. Maybe theta will be equal the arc length over the radius. Now these are very important rules. Also, we need to do an area of the sector. So if I'm doing a circle, and that's my central angle, this is going to call a sector. That's a sector. So a sector, the area of the sector is equal to 1/2 r squared theta. And again, theta should be in radian. So let's start with the first question here. In this question, I want to find the missing quantity and the area of the sector. It gave me the diameter 10 meters and theta 135 degree. So what is missing? Based on the triangle I gave you, S equal R by theta, I am missing S. But I don't have R, I have diameter. So from the diameter, The diameter is double the radius, so r will be 10 over 2 divided by 2, which is equal 5 meters. That's the radian. Theta is on degree. I need first to change it into radian, which is equal to 3 pi over 4. Now, S equal r by theta, which is equal 5 multiply 3 pi over 4. That's going to be 15 pi over 4 meters. Now you can paste on the question. You might change this into decimal and round it to the nearest one decimal place. It will be 11.8 meter. If you round it to the nearest two decimal places, it will be 11.78. That's from the calculator. And if I say round it to the nearest whole number or to the nearest meters, that's going to be 12. So you need to know. So that's the nearest one decimal place, two decimal places, or the nearest hundredths. This is nearest whole number or nearest meters. Now I need to find the area of the sector. So the area of the sector is basically 1/2 r squared theta, which is equal 1/2 multiply 5 squared multiply 3 pi over 4 in radian. That's going to be 75 pi over 8. And if I ask you to round it to the nearest square meters, that means a nearest whole number, that's going to be 29 meters squared. So that's the nearest whole number or nearest square meters. Now, let's look at this question here. A pendulum swings through an angle of 20 degrees each second. If the pendulum is 40 inches long, how far does its tip move each second? Round your answer to the nearest two decimal places. Well, let's draw a pendulum. That's a pendulum. And it moves. So it goes this way and goes back. So it might end up here. So it goes this way and this way and so on. So by looking at this is going to be my theta. And this is my r. From here all the way to here is r. And this one here is going to be s. So let's go back to the question. He goes theta equal 20 degrees. I need to change it into radian. Pi over 180. That's going to be equal pi over 9. Now, next, I need to, he gave me the r. The r is 40. Now I could find s. S equal r by theta, which is equal 40, multiply by over 9. That's equal to nearest, I'm going to use it nearest whole number. That's going to be 14 inch. Can you do calculation? You can do it into two decimal places. I'm just going to ignore this now. I'm going to only make it to a whole number. Okay. Now, sometimes they must ask you about the area. He did not ask in the question, but I'm adding this question. Let's say that he's asking about the area here. So I will say A equal 1/2 r squared theta, which is equal 1/2 by 40 by pi over 9. And again, to the nearest inch squares, that's going to be 279 inch squared, if he's asking about the area. Now, in this question, a water sprinkler sprays water over a distance of 13 feet while rotating through an angle of 135 degrees. What area of the lawn receives water? Now, let's draw that sprinkler. It's here where the water sprays all the way this lawn, covering an angle here 135 degrees, covering this area. He wants me to find this area in which we know that the distance goes all the way to 30 feet. That's my R. I need to find the area. A equal 1/2 r squared theta. Now I do have r, I have theta in degrees. I need to change it into radian. Multiply by over 180, that's equal 3 pi over 4. So you go here, equal 1/2 by 30 squared by 3 pi over 4, which is going to be equal to around 1060 square foot. That's to the nearest whole number. We're done, guys. Please let me know if you have any question, and see you in the next video. Bye bye.